Welcome back, folks. So today what we're going to do is we're going to have a look at this this little what is it here? It's a 830 series digital multimeter. Comes in a box like this. It's pretty much the world's cheapest multimeter. I think including shipping I paid probably a bit less than $4 US, maybe about $6 Canadian for it. So it is pretty cheap, and I hear that a similar item can be had for free going to some of the bigger hardware stores like Harbor Freight down in the US. But this is in particular model. This is a DT-830D. Fit and finish, as you saw in the unboxing video the other day, is pretty bad. Like this label on the front here is off center. I mean, how much could it take to actually put that on properly, especially if you're doing hundreds or maybe thousands of them a day? But anyway, so that's the level of care that's gone into this thing. But anyway, we're going to run it against its potential stablemate. So the idea of getting this was to have a second meter in the beginner's toolkit, which we haven't topped out the value of yet. So I'm adding little bits as we go along, and this I thought would be a nice addition as a second multimeter, in the cases where you want to measure current and voltage at the same time or something like that. Or if this, 1 meter, your prime meter is busy and you need to go off and do another measurement somewhere, it's handy to have a second meter. All right, so I'm going to then compare it to this. I know this is accurate. I've already run a series of tests on this, and it's within its stated accuracy, so it's fine. So I'm going to use this as the benchmark. And according to this little sheet here that comes with this, which is actually, it's not terribly bad. I mean, the translations are pretty good. It's readable, and you can understand what they're saying. It gives a little overview of how to work it, how to use the various different ranges and stuff. But it also gives here, point of interest is the specifications of it. And it's roughly around about 1 to 1.5 volts accuracy on the DC voltage ranges, about 2% on the AC, which is going to be of limited use to us. I am going to test this using the mains, but that's probably the only time it's ever going to get used, and from my perspective on that. DC current ranges 1.5 to 3%. 3% is in the 10 amp range. And most of these are plus 2 digits. The AC voltage range is plus 10 counts. That's quite an enormous amount. Again, the ohms range 1.2 to 1.5%, 2 counts. So it should be pretty easy to have to see if within these specifications or not. But still, I think for the use that this meter will see as a part of that kit, I think if any part of it was within 3%, I'd call it pretty good. For the price you pay for it as a backup meter, that'd be fine. So let's take a more careful look at it then and run it through some of its paces. Okay, the first range we're going to try it on is 200 millivolts. You can see that the Kyreets is measuring 184.46. Let's see what this one does. 186. Oh, well, that's within spec. Okay, so let's take this up 2 volt range, and we'll also take the power supply up. Okay, so we got 1.88. 1% would be up to 1.9, and we've got that here. Okay, up to the 20 volt scale. We'll try to get around 19 volts going into it here. Yeah, that's within spec as well. We're doing pretty good so far. Now it's hard for me to test up here at the 200 and 1000 volt level. I just don't have that kind of power available to me. But I do have 100 volts. All it's good. Yeah, so the 200 volt range, 1.2% and 2 counts. Yeah, we're within that. All right, so let's go and we'll just check out the AC voltage here. So I'm just going to check both the 200 and the 750 volt scale out on the mains. So let's do that. Okay, so here we are. We're hooked up with the mains here, and we can see that our AC voltage is on the 200 volt scale. Resolution has no really go 2%, plus minus 2%, plus 10 digits. It's well within that. Okay, let's pop it up here to on the 750 scale. Yeah, it's performing pretty well so far. Get out of here. Get set up to do ohms measurements here. Set this up for ohms. I set this up for ohms. Start off in the low range there. Okay, we're set up to do ohms here. So we'll do the Kaiwits first. So 1.14121. Okay, let's see what our world cheapest multimeter says. So it must be picking up some resistance in the cables and the connections, just like the Kaiwits was. What is its closed circuit ohms here? About 0.5. So if we subtract 0.5 from what we see here, we're right on. Okay, let's go up to the 100 ohms. We'll do this one first, and we'll pop over to the Kaiwits. 98.4. Let's see what the Kaiwits has to say. 100.29. Okay, we're well within spec so far. Okay, what does the Kaiwits say about this? 1000 ohms. And what does our little DT-830D say? It all seems to be down just a little bit, but at least it's consistent, and it is within its specifications, so can't complain so far. Okay, 9K. Next range. Exactly the same 9.8 again. Okay, and the Kaiwits should be 10K here. Yeah, Kaiwits is a little bit better, but this is within its specification so far. Okay, what's it say about this one here? Get up to the next range. This is supposed to be 100K. A little bit further off there, but I think it's still, yeah, it's still within specification. Right on the edge though. Let's see what the Kaiwits says. Okay. Last one, the Kaiwits says 10 mega ohms. I've got no way of doing 10 mega ohms on this one, so we'll leave it at that. But so far, so good. Not spectacular, but then again, it's not terribly bad. All right, we could check it out in some diodes, but I'm not even going to bother to compare that to the Kaiwits. Now it'll probably be able to manage the first two. .258, 0.25, that's fine. And the next one, 0.730, 0.62. It may be putting through a little bit more current than what's ideal, so I wouldn't worry about that. Now I expect it to fail with the red LED, but it lights up all the LEDs to some extent, yeah. So yeah, just for chits and giggles, let's check the Kaiwits to see if it does a little bit better job. Far less current is more accurate. Now, but how's it do on the diodes? Well, it gets the red LED. It gets the amber LED. Will not get the green LED, and will not get the blue LED, but it's two LEDs above this. All right, so let me set up for current measurement. I'll be right back. So we got this set up. I've got the power supply set up to 1 volt, and I've got everything running through this resistor here. I've got the resistor is set up for a value of around about 500K, and giving us an output here. I'd like to get close to the top of the range as possible. So 19.22 here, 19.3 there, that's perfectly within tolerance. All right, let's go up to the next level, which is 200 microamps. Let's get it up to closer to 200 here. Nearly perfectly matched. No problems there. So let's go up to the, this I guess would be essentially a 2 milliamp range. So that matches that there. So let's put this up here as well. Let's bring up the current a little bit by bringing up the voltage. Yeah, that's great. All right, now we go up to the milliamp scale here on this meter. We can leave the Kaiwitz where it is. And it's showing an overload. That shouldn't be. Bring the voltage down. Okay. Okay, so when there's the 124 microamps going through the Kaiwitz, so it must be that's what going through the circuit. This is reading 18.6. That's crazy. 8.6 milliamps. No, that can't be right. There's got to be something wrong there. Now this is matching here if it was microamps, but it's on the 200 milliamp range. There's something not quite right going on here. There must be something amiss with the shunt resistors for the 20 milliamp and 200 milliamp ranges. Okay, we'll have to look inside the thing, and I think I found a schematic for it, which I'll probably have to go get. But for now, let's try the 10 amp range and see how that works out. Okay, so we've got 1 amp going into it, and that looks pretty good. Don't mind that beeping, that's just the power supply saying that we're in current limit mode. So I'm just going to increase that current limit up to 2 amps. 2 amps looks good. 3 amps. 3 amps looks good. And that's about all we can get out of that power supply, but I'm okay with that. I'm okay at leaving it at 3 amps here. All right, so at this point in time, I think we've tested out most of the functions we'd be interested in for this meter, and now time to tear it apart. Yes, there's not much going on in here. Now, I took a closer look at this, and yeah, there is no fuse in there, so this is a complete lie. It's actually, there's a trace across here. Okay, just popping this apart. To have a look inside it. This is the meter, by the way. Some improvements can be made, like for instance this beeper here. We can drill a hole in the side of the case so we can actually hear the beeper. I did remove the board and have a look underneath. There's nothing on the other side except for the switch pattern. No components whatsoever. So it's just this chip here, a few resistors, and we've got a diode here. And that's about it. The rest of it's just a few resistors. And one thing that did happen was, you know, in moving it around here, this whole thing fell off. Now, I did trace this out. So it fell off of here and then was dangling and then broke the, I don't know if you can see that or not, but kind of broke the trace right off the board. So I'm going to have to stick this in with something and then jump her over. Now this right here is the pin off the controller, the chip, the cob here, that comes out and powers this little beeper. So what I'm going to do is I'm going to drill a little hole in the side here so it makes it a little better, and then I'm going to solder this back down and run a tiny little jumper over, and hopefully I'll do a better job of soldering it down, and I'll use something like hot snot or something like that to just hold this thing in place here. Okay, so I got this schematic. Now this is for the 803B, but they all use the same chip, the same design. They just, I think between going from its original version, which was probably a pretty good little meter, all the way down through the different iterations, they're just trying to figure out how to make it cheaper. Like for this one here, you know, it shows a fuse, and this one obviously doesn't have a fuse. It's just a straight trace through there, which I could cut that and put a fuse in. But then it comes the question of what value of fuse you put in. It says here you got a 0.2 amp, 250 volt fuse, and this says here 250 volts, 0.5 amps. Now we get to the shunt resistors for the milliamp ranges. We got them here. So they come up from the connection at the 10 amp lead, which has got this 0.01 ohm resistor, or this shunt bar here. So this is the point here, and it comes up. So these two look like they're the resistors that should be in there. And it looks like the first one is supposed to be 1 ohm. And the second one is supposed to be 9 ohms. And when I look at these under a magnifying glass, this one here says 9R, and this one here says 1R. So the first thing I'm going to do is I'm going to check those, because if they're open or wrong, well, they're not open because we were getting something. We're getting microamps going through, It's some indication that these resistors are the wrong value, even though they're marked 9R and 1R. Let's have a look. We'll use the Kaiwich to do that. 1 K ohm. Oh, that's interesting. Make sure I got that right. 1 K ohm. Okay, let's measure the next one. 0.5 K ohms. So it should be 1.5 K ohms from here to here. Yeah. Well, that's not what I expected. I would expect 9 ohms here, 1 ohm here, and 10 ohms the entire way. Okay. Since we've already done quite a bit of surgery on this thing, let's continue. What I'm going to do is I'm going to try and put some resistors in here. Now, I don't think I have values in surface mount resistors, but there's lots of room here. But what I do have is I have some regular resistors. And what I can do is I can remove these, put a 1 ohm resistor from here to here, and then put a 10 ohm resistor up between here and here. Okay, we're back from surgery here. I'm going to measure now. We should have from here to here, we should have 10 ohms. That's right. And from here to there, we should have about 1 ohm. Bounce around a little bit. I'm sure there's some lead resistance in there, so I think that's going to get us close enough for our purposes. Maybe not within spec. Here we got, this was reading 19.48 and this is reading 19.24. That's definitely an improvement, and I'm going to be happy with that. Okay, so let's now, we'll take this up to the next range, 200 milliamps. Okay, we've got 190 milliamps going through it. This is reading 190 milliamps. This is reading 1.9. Okay, well, it's reading 1.3 ohms. This range, I imagine it's reading about 10 ohms in that range. Yeah, so the resistances are right. Maybe there's a bad switch contact. It's not telling the meter that it's in the right range. It looks like it's telling the meter it's in, I don't know what 1.9 would mean. Yeah, there we go, 190 versus 1.9. Well, that's the best I can do with it. I'm not sure I can recommend to anybody anything that out of the box I have to do several repairs to in order to use it. And so, okay, we didn't test the continuity on camera, and the whole reason why I remounted I remounted this because because it fell off, but the reason I put a hole in it was to get a little bit more sound out of it. So let's show you what that means in reality. It makes a noise, but I can't hear it. Like standing here, I can't hear it. If I put my hand here and cup like that, I can. So it's really, really bad in the continuity mode, and it's not even that fast. I mean, it takes about almost half a second for it to produce a sound in continuity mode. Now, if you're a patient person, that's not a problem. So ohms ranges are fine, DC volt ranges are fine, AC volt ranges are fine. The microamp ranges and up to the 20 milliamp ranges are fine. The 200 milliamp range is lost its mind, and the 10 amp range is fine. Diodes, it checks, Schottky, germanium, silicone. That's it. It won't check anything like LEDs and stuff like that. So, but again, like if I get a meter and I have to do surgery to it to get it just to work, I can't recommend it. So I'm not going to be putting this into the beginner's electronics kit. I will leave it lying around here until I find another need for it. Maybe I'll just throw it in the glove compartment of my car for, measuring my battery if it goes dead or something like that. That'd be fine. But anyway, folks, that's it. Thumbs down on this little thing. I mean, I know it's only $4, but it's not even worth that. It would be if you got one that worked out of the box, and I don't know, I'd love to know if anybody has one. What happens in the 200 milliamp range? Do you get that strange digit there, or is mine just special in that respect? And yeah, let me know if you have one of these, how it works, or if you got so frustrated that you threw it in the garbage. But yeah, I don't recommend you buy one of these at all, not for any reason, because you could get one as bad as this, or possibly even worse. So thanks for joining me, guys. See you in the next one. Have a great day.